Hello again and welcome back. Today we're going to be going over some algebraic properties. So these are things that work no matter what. So we're going to start seeing some letters pop up here because they're going to represent any number that we would want them to be. So our first property here is the commutative property of addition and the commutative property of multiplication. So what this says is that we can switch things around. So here we have 2 plus 3 is the same as 3 plus 2. So we can swap our terms with addition and multiplication, same as 2 times 3 is the same as 3 times 2, or A times B is equal to B times A. So that's saying that we can just flip-flop things. So when we're adding or multiplying, the order of the terms does not make a difference. So the word commute actually means to travel to. So we all commute to school, so we switch our position from home to school and then back at the end of the day. So commute, commute, commute. We can swap things around and it does not change it. And here for addition, we have 5 plus 3 is the same as 3 plus 5 because they both give us 8. Then with multiplication, 5 times 3 is the same as 3 times 5 because they both give us 15. So one thing we want to remember is the commutative property does not work for subtraction or division. So if we take a look, 5 minus 3 gives us 2 here, and then 3 minus 5 gives us negative 2. These are not equal, so it does not work. Same thing, 15 divided by 3 gives us 5. 3 divided by 15 gives us 0.2, definitely not equal, not even close to being the same. Alright, next we have the associative property of addition. So this has to do with grouping things together. So when we are grouping things with addition, it doesn't matter which way we group them. So we have 2 plus the quantity 3 plus 4 is going to be the same as the quantity 2 plus 3 plus 4, or in abstract form here. So any number A plus any group of numbers B and C added together is the same as adding A and B and then plus C. And the same works for multiplication. So when adding or multiplying, the way terms are arranged, or we can also say grouped, makes no difference. So to associate means to hang out with. So associative property, it's the way we're making these numbers hang out together. So when we follow PEMDAS, even though our steps look different here, we get 3 plus 5 first gives us 10, 3 plus 7 first gives us 10, 10 plus 5 is 15. Well, that's going to be the same. Even though it looks different in this step, we end up getting to the same answer. And the same for multiplication. Sorry, there should be a 1 there. 105 is equal to 105. The associative property, once again, does not work for subtraction or division. So if we follow these steps down, then we notice we get 2 different answers for subtract. And if we follow this down, we get 2 different answers for division. Next is the distributive property. So we can see that we're taking this 2 and multiplying it by 3 plus 4. And that's going to be the same as multiplying 2 times 3 and then adding 2 times 4 after. Or in abstract form, we have it here. Same thing with subtraction here. So we're going to start seeing no multiplication symbol. If we see 2 letters together, that means we are multiplying here. So if any excuse me, 1 second, sorry. If any number or variable stands outside and multiplies, whoa, come back. the parentheses, it also has to multiply everything, or it has to multiply everything in the parentheses. So we oftentimes use arrows to show this. So we're doing 3 times 7 to get that 3 times 7, and then 3 times -5 to get that piece there. And we can work our way down and get our answer there. Alright, so next we have the property of the additive identity. So when we add 0, the identity, or the value of the number, does not change, or the variable. So one way we can say this is that 7 plus 0 is 7. So any number plus 0 is going to be equal to that number. So there we have an example with a variable to show that any number plus 0 will be the same. And then here's just another concrete example there. 1/2 plus 0 is equal to 1/2. So 0 itself is the additive identity because it does not change the number when we add it. When we multiply by 1, so multiplicative identity, when we multiply by 1, the identity, once again the value of the number or variable, does not change. And here we've got the same kind of examples going on. 7 times 1 is going to give us 7. Any number that I choose C to be times 1 will give me C back. And once again, 1/2 times 1 is equal to 1/2. So identity, that means it does not change the number. So multiplying by 1 does not change it. So 1 is the multiplicative identity. Adding 0 does not change it. So that's the additive identity. Next we have the 0 property of multiplication. So that just tells me that any number times 0 will be equal to 0. So when we multiply anything by 0, the product will always be 0. So 7 times 0 is 0, C times 0 is 0, 1/2 times 0 is 0, anything times 0 is always 0. Next we have the additive inverse. So the purpose of this property is to get an answer of 0 in the end. We use this property to solve algebraic equations, so we'll see that later on in this year. So 2 plus -2 is 0. 1/4 plus -1/4 is 0, and a plus -a is 0. So what we're doing here is we're just adding the opposite so that the things we're adding cancel each other out and become 0. And just like the additive inverse, multiplying has an inverse, so the purpose of this property is to get an answer of 1. So 2 times its inverse, 1/2, will give us 1. -5 times its inverse, -1/5, will give us 1. And any number times 1 over that number will give us 1. So we are trying to multiply by the reciprocal so that the factors will equal 1. So remember, reciprocal just means flip the fraction, right? So the reciprocal of 8 would be 1/8. So when we multiply 8 and its reciprocal, we get 1, just like with any other number. Alright, so here we are going to fill these in. So b plus 0 equals b. Well, that was the additive identity, right? We get the same number back that we added 0 to. And then we have multiplying by 0 gives us 0. So this will be the 0 property of multiplication. B times 1 gives us b. Well, that would be our multiplicative identity. We can switch anything around that we want to when we're adding, right? So this is going to be the commutative property. When we add the opposite to some number and get 0, remember that is the additive inverse. We have to multiply b times both things in there. So that would be the distributive property. Things when we're adding together, remember, it doesn't matter how they're grouped together when we're adding all of them. So that would be the associative property. These things hang out together and it doesn't matter how they're ordered. We are multiplying by the reciprocal of 99, which is 1/99th to get 1. So when we multiply things to get 1, that is the multiplicative inverse. Once again, we're multiplying b times both things in the parentheses here, right? So that will be the distributive property once again. C times 0 equals 0. That's going to give us, so that is the 0 property of multiplication. And then once again, we are multiplying 2 times both things in there. So we are distributing that 2, which is C, the distributive property. Here again, all these numbers are hanging out and being added together. Doesn't matter which ones we group together. So that is the associative. And finally, Susan had to solve this problem here. She rewrote the problem like she switched a couple things around because it was easier to add 25 and 75 first. So what property allowed her to do this? Well, which of our properties says that we can flip-flop things around and it doesn't change? Well, that is the commutative property, or we would write that out. Commutative property. All right, so those are all our properties. Check out the notes in your assignment if you feel like you're getting stuck, and make sure that you complete that assignment and get it turned in on Canvas. Thank you, and we'll see you later.